Hello, everyone. How are you all doing today? Good. Awesome. So, like what was mentioned, my name is Peter Haddad. I've been working at Lockheed Martin my whole career. So I started out interning there and then worked at Rotary Mission and Systems, specifically working on simulation environments. And then now I work at the corporate level, providing support to the entire corporation. So it's a lot of fun. So at first, we'll be discussing Lockheed Martin's AI Factory, how we've adopted Ray into that AI Factory and how we're accelerating solutions. And then lastly, we'll go over a use case which was presented at the NVIDIA GTC conference as well. So very excited and looking forward to sharing this. So let's first talk about Lockheed Martin's AI Factory. So we're a team and a platform at Lockheed Martin, and we focus on adopting modular components that fit into all aspects of the machine learning lifecycle. So we want to ensure that we have trusted AI ML solutions. We want to ensure teams can easily onboard themselves onto those solutions and leveraging them depending on their use case. Because Lockheed Martin has a few different business areas and there's just a large diverse set of different use cases, we want to ensure that they can take particular components that we provide and they can run off. And our goal is to make it easy for new practitioners of machine learning to get involved and start leveraging our capabilities. In addition to that, we also have some advanced and really smart researchers at Lockheed Martin doing specific tasks. We want to make sure they can just jumpstart, get onto our platform, leverage our infrastructure, and start developing. And lastly, our technological stack is deployable via Kubernetes. So as long as there's a Kubernetes cluster, we can deploy our tools on top of it. So let's talk about some of our capabilities. So the roofing of all of our capabilities at AI Factory is our infrastructure. Without infrastructure, none of this would be possible. I know we've been talking about infrastructure and LLMs a lot at this conference so far, which has been great, and that same applies to Lockheed Martin. In addition to our infrastructure, we want to ensure that we have security across all of our different capabilities. So whether that's data versioning, data labeling, or machine learning pipelines, training, or even edge inference, we want to ensure that that's locked down. People can do it effectively and have peace of mind that they're secure. So this part really excites me. So at Lockheed Martin, I'm a machine learning engineer, and what's great about the AI Factory team is that we have a lot of cross-pollination, meaning that we all work really close with one another, and I get to actually touch a lot of these different infrastructure environments, and it's a lot of fun. So we have a few different environments I'd like to focus on today. We have our centralized AI Factory platform, our air-gapped and isolated environments, and our AI Factory environments in the field. So our centralized platform is consisted of large GPU clusters that are multi-tenant, meaning that different groups' work is actually isolated and it's secure. In addition to these on-premise large GPU clusters, we have our scaling cloud deployments. So this is very beneficial because if there are a couple groups at Lockheed Martin that want to run a particular workload, say for example for a week, a month, they can spin up that cloud environment and then tear it down. Next, we have our air-gapped and isolated environments. So let's say a team at Lockheed Martin has their own infrastructure, and they want to deploy our tools and capabilities onto that infrastructure. They can do that through our infrastructure as code and our modular components. So like mentioned, they can easily just pick and choose what they want to deploy and start running with it. Lastly is our AI Factory in the field. So this is an actual physical server that can fit onto an airplane. It's pretty decent size. It's not too big, but it's really heavy. I actually got to pick it up a few weeks ago. It was a workout. But this is really cool because we can do training on the field or we can do data collects. And it's just extremely powerful dependent on that mission that we're supporting. And in summary, what's really exciting about the infrastructure is once we're done with the edge infrastructure and our environment, we can then take that back to our platform or our air-gapped environments and offload that data, do things such as after-action reviews or do more retraining at scale, which is really cool. So Ray, where does Ray fit into this? It can fit into any one of these infrastructure environments, which is what's powerful. And depending on the use case at Lockheed Martin, we can scale, parallelize, or just leverage that capability. And we'll dive into that here in a second. So let's talk about the adoption of Ray at AI Factory. So initially, in March 2022, we wanted to leverage RLlib. Then we did some advocacy once we ensured the solution worked. And then January 2023, we started looking into Ray data. And then in February 2023, we did Spark external simulation environments. And lastly, large language models. So let's go back to the beginning. So initially at Lockheed Martin, we had this technological stack, and we needed a tool to do reinforcement learning. So we thought, okay, RLlib, it's a really good library. It allows us to do reinforcement learning at scale, and we can even integrate it with different environments or simulations down the line. Once we went through some challenges of adopting Ray and getting it available to our user base, we started to host those advocacy workshops, and we even have an advocacy team to just spread the word of Ray and the capabilities we have at LM. After we did advocacy, what's exciting is the users came to us saying, hey, there's this really cool API we want to try, let's test it out, such as Ray data. So we started doing Ray data pipelines and integrating that into our current stack. And then in February, which is really interesting because not only are we in the Ray ecosystem now in that particular GitHub project, we're branching out. So if we look at RayDP, which is the Spark, PySpark wrapper on top of Ray, we can leverage that. We've been doing KServe and then those external simulations. And then lastly is the fine tuning of large language models. So this is still ongoing. Interest is spiking very high, and it's exciting to see. So there are a few different implementation challenges we faced when adopting Ray originally. I really hope that these challenges can help you all or help the future adopters of Ray. So let's talk about the first one. We have security. So on our platform, we are unable to run containers as the root image. So we had to work through some challenges, specifically on the code side, how Ray had their code developed, to ensure that the code wouldn't even run, right? You'd start it up, get a ton of errors, and you'd be like, oh, this isn't good, this is upsetting. So we wanted to ensure it worked. For the rootless images solution, the big piece was the GPUtil package through pip or Python. When you have that installed on your Ray image, it allows you to bypass reading from specific directories at the root level. So simply by installing that package, ensuring it's on each image, we were able to mitigate any other risks. Next, we have SE Linux. So when we run our large-scale multi-tenant Kubernetes clusters, we have them isolated and locked down, meaning every single pod has to run with SE Linux, and we had to make sure that Ray understood that context. Lastly, for the security section, we have authentication and authorization. So this one's exciting. So say, for example, on our Kubernetes cluster, we have lots of different Ray clusters. We don't want one user to be able to access another group's Ray cluster. So we had to work through those challenges. Now for the networking component, at Lockheed Martin, being a big corporation, we have proxies and certificates. And we wanted to just increase the user friendliness and the developer experience. And we did this by providing custom AI Factory hosted images. So essentially, those come baked in with those proxies and certificates. That way, it's just every single time a user wants to be onboarded, it's very easy. So we really want to focus on the developer experience at AI Factory. We find it very important, and it's just fun, when we're helping people solve problems instead of these tiny little technical difficulties that can get annoying. Lastly is installation. So with installation, this is more if the team has their own infrastructure. So we have to ensure that they have security approval of all the different dependencies, whether that's software, whether that's even a Kubernetes cluster. We have to ensure that we can provide things such as vulnerability scans on our containers and also software bills of materials. So we give them that list. as we increment and update our infrastructure as code, they can get an updated list and get approval for that. All right, let's talk about some of the contributions. So on the last slide, we talked about authentication and authorization. Lockheed Martin made it possible to authenticate to array clusters with bearer tokens. So I'm not going to dive into the fine details of how we do auth, because that's not always super exciting to everyone. But we were able to contribute some changes back to ensure that we can authenticate and we have multi-tenancy at our infrastructure level, but people are isolated at the array cluster level. Previously, before we had these changes made on the open source project, we maintained an internal fork of Ray. So every single time you'd want to use Ray, a team would have to install their fork. We did something called monkey patching, where you just patch the code, and then it would install the upstream Ray packages. Secondly, we have KubeRay. So what we noticed with KubeRay initially, so earlier on last year, June, July timeframe, as we got more adoption, we had more Ray clusters, and we just noticed that the Ray operator couldn't keep up. It was just unable to do so. So last year at Ray Summit, had some contributions and discussions where we said, okay, what if we had the Ray autoscaler inside of each Ray cluster? That way, each Ray cluster is handling that component. And then lastly is examples. So with advocacy, at Lockheed Martin, we don't want to host our own examples. Obviously we do, but we don't want to host all of them. We'd rather refer to the documentation of Ray or some other tutorials and examples. So there were some specifically on the RLlib side that just didn't work out of the box because of our certificates and proxies. So we ensured that we could run those easily. In addition, with 2.7, there's a feature called Ray Job CLI. So instead of using, say, for example, the Python SDK, you can use the CLI. We also added some contributions so you can pass bearer tokens when using that CLI as well. And that one was fun because there was another organization, I forgot the name, but they were contributing the same issue back, and we were like, okay, which one do we keep? But we worked it out and we solved that together. It was a lot of fun. All right, let's talk about accelerating solutions. So let's say, for example, a new team at Lockheed Martin wants to do some model training and serve it in production. So for example, they want to train, tune, and serve a computer vision model for detection and classification of animal images. So we'll first onboard the team, do some training, and then we'll get them into a production setting. So let's talk about the onboarding step. So AI Factory has an in-house platform that makes it super easy for teams to spin up Ray clusters, manage their resources, create custom Ray workers with their own images or our images, and even monitor their clusters themselves. So this is really easy when it comes to leveraging Ray and getting new teams onto it. And lastly, we want to ensure that teams at Lockheed Martin can iterate quickly. That development cycle, we want to make it fast. So we provide workspaces and Jupyter notebooks to ensure that they can test their solutions on a local Ray cluster and then submit it onto the actual Ray cluster for scaling. So on the right-hand side, we have a Ray tune job running. A couple of points I want to point out here. We have our GPU utilization to the max, which will appear here in a second. And we have our memory almost maximized as well. And we're just running a few trials here and ensuring that it's fault tolerant. So the key point here is that when users are leveraging AI Factory's infrastructure, we want to ensure that they're maximizing the Ray clusters. So we want to ensure that utilization is very high. We don't want them, say, for example, claiming 10 GPUs and only using 2% of a GPU, because that can happen depending on your workload. Or say, for example, they are claiming GPUs, but they only need CPU-based workloads. We want to ensure that the documentation is clear and we provide that advocacy. So after training is finished, we store that optimized model into our internal model registry. and now we serve it. So here we're just submitting a job, a Ray serve job through the Python job SDK. We can see it's running, and then bam, it succeeded. So now we'll jump over to the inference notebook. So we're going to run inference on an image of a cat. Look at that, look at that. You see, we can see that the cat was detected. I don't know, I'm a cat person. I don't know about you all, but I love cats. Oh, I've got 2 at home. I'm not going to talk about it. It's okay. Cool. So lastly, we'll talk about the weld defect detection use case. This is essentially detecting defects in weld surfaces through a camera feed. So let's talk about the legacy solution. So initially, there's a solution called dye penetrant testing, inspection, and it's just very environmentally friendly, slow, and I think we could do it better. So the goal with this use case is to eliminate this old method and move to computer vision and object detection. So we'll talk about some of the results. So with a baseline object detection hyperparameter search, we saw that our mean average precision was fairly low, which isn't good. And the big point I want to point out here is that the real hours of training was really slow. It took 50 hours to get bad results. Now, when we look into Asha and Ray Tune, we can see that the results are just outstanding. We have better accuracy, better precision. Our real hours of training is much less, even when we search over more hyperparameters, and our GPU hours are outstanding. And this is possible because Ray allows us to distribute our workloads and trials, or even the same trial. So by using Ray and the Asha algorithm, and Asha specifically allows us to stop non-performant trials as the job runs, we just get a huge increase. And the lead of this effort, he also presented at NVIDIA, they were able to reduce their training time from days to hours. And that's just a spark, right? When you have an organization and you share these success stories with that organization, it just builds that community of, okay, we're doing this, but we can just do it better. So it's very exciting to me. Sweet, so these are just some results. On the left-hand side, we have the camera feed detecting welds with the default hyperparameters. And then on the right-hand side, we can see that it's doing a pretty good job detecting these defects. So the hyperparameters selected via Asha, there's even some noise, so you can see shadows, and it doesn't even affect the algorithm results versus the default parameters, it's not as good. So please feel free to scan the QR code or go to the link. Frank Phillips dives into the math, the architecture. I think it's a really good talk. It dives into exploring other components besides Ray, and it also explores why they went with Ray in the first place. Cool. So in summary, Ray is very great because it allows us to solve many distributed scaling challenges. I just love Ray because it is really easy to use. And so you can get onboarded, leverage it, do some basic like Python code, and then scale it at large. And the unified Python API or SDK allows it really easily for developers to get onboarded and to just run with it. So we want to focus on that developer experience at AI Factory because it's just really important when it comes to new teams or experts doing machine learning. And lastly, we think Ray can do better. I've had lots of discussions with the community last year and ongoing. I think when we scale it out at a corporation level, when we have lots of users accessing that same Ray cluster, we can see some challenges. So we want to help contribute those fixes back, and we want to have those discussions with the community to make it better. I've seen some great talks throughout today and yesterday, and it's outstanding how far Ray's come. Sweet, so thank you so much. I'd rather have a lot of time to have a discussion, so let's answer some questions.
Small room, I can talk pretty loud. So within your AI factory, the various components that you mentioned, is everything kind of bespoke, homegrown, or are there a variety of open
Yeah, great question. There's some inner source solutions. For example, our model registry that I mentioned is inner source, but we gravitate towards open source. I think that's the best way to go. We do have some vendors we work with, but when it comes to selecting solutions, it's all open source. And what's interesting is that Lockheed Martin, when I first started, Alan Hone, one of our directors who does software strategy, he's been pushing for, working with open source software since day one. So, just from when I started versus when he started pushing on that effort, it's like been an insane change. So it's really awesome to see.
As a follow-up, can you mention any of the vendors or kind of core open source platforms that you utilize?
Yeah, definitely. I can think on it, but let's have a discussion afterwards if you'd like. Yeah. Yeah.
Back at the security slide where you were showing about, I was running with Liz equipment, really about the vulnerability scan part. I was curious, have you run into much where you have to patch, and so can you do that just by managing point releases on dependencies, or do you actually have to run the patch?
Yeah, definitely. So we were doing some contributions back to Iron Bank to get Ray, approved. It's just better for getting faster security approvals, and that specifically, yeah, we have to patch. We have to use our UBI 7 image specifically, so we have to ensure Ray can work on UBI 7 or UBI 8. So yeah, there is a lot of patching that goes into it, depending on the software, right? And then some tools that we leverage have tons of containers just to even run. So it just depends on the tool as well. Awesome. Open for any question, even if it's a discussion also.
Great. Well, if there are no more questions. Oh.
Yes. Perfect.
So I'm curious, what is the developer experience? Let's say I want to start using AI Factory. Do I have to program, write code directly on Ray API, or you guys provide some higher level abstractions, to make, life easier for developers ML engineers that just started their career? Maybe.
Yeah. Oh, sorry. Yeah, definitely. I think for the most part, we try to challenge them to get into the field of software a little bit more. Python specifically, we don't try to we'll try to manage components. So on the if we're okay, write the code, we'll help with the image management. So say for example, they want to run an image with specific dependencies, we'll ensure that we help out there. But yeah, for the most part with Ray specifically, we delegate all that work. But we provide documentation and training, and we host internal workshops. But yeah, we definitely want to build a culture of us helping them. We want to have that culture where they can ask questions and feel comfortable asking questions. So whether that's in a one-on-one setting, or if that's in a group setting or a phone call, I take it personally to ensure that everyone feels comfortable when working on these new technologies, because it's just rapidly changing and there's just so much new stuff. So whether it's Ray or a different tool, there will always be learning.
Another one, you mentioned edge hardware and some of the deployments. What sort of key? Oh, full disclosure, I work for SAIC, so you're familiar with us for competitors, right? One, can you describe or mention what hardware you're using on the edge?
Yeah, definitely. So I'm not the hardware expert, unfortunately, at AI Factory. Specifically, we use GPU-based workloads mostly, but yeah, unfortunately, I can't really dive into the specific specs and the the company and all of that.
Thank you.
Yeah.
Hey, Lisa, thanks so much for the talk. Alex, I'm also going to be speaking in that room, and I also need to thank the meeting again, so I'm looking to you as well.
Awesome.
So yeah, I've really enjoyed seeing together. Just curious, can you tell us a bit more about what the generative AI use cases are shaping up?
Yeah, definitely. So I think there's a couple of phases. One is fine tuning. So we're doing a lot of fine tuning. Some of it's document searches, or how do I find this resource at Lockheed Martin across all these different business areas, and how do I ensure it's in my business area, because that similar document may exist somewhere else. So we're working on fine-tuning models for that. We're looking at a lot of open source options. Like we are constantly evaluating and deploying and serving these new like models such as like Llama or other open source solutions. So it's very interesting and it's very fast. But we have Anthony Hawkins in the audience as well, and he's doing a lot of the LLM stuff.
Maybe one question with regards to the size of your DevOps team behind that infrastructure. So how many people with skills are you employing?
Yeah, definitely. We've got about 30 engineers. What's really cool about our team is our senior managers are doing development with us. So we have a culture where we work with one another in engineering calls. You'll be like pair programming with a senior manager, and it doesn't change. You don't get nervous about it, or you don't, and it's really cool to see the new team members working with those, and almost every day even.
I was just going to ask, can you speak, I know you said Alpha was boring, but it's sort of interesting to me. Can you speak a bit more to the contributions that you made with regards to Alpha?
Yeah, definitely. So Auth&Array, specifically when we first adopted it, we were using like internal networking through Kubernetes. So like, say for example, your workspace is running in a Kubernetes cluster, you can just easily access it. We said, okay, what if developers want to use their local computer to connect to it, or have better isolation? Because there's still security risks with that. So the big contribution back was on the gRPC side. So with Ray init, when you create that client connection. So essentially we made it so you can pass in metadata or headers through each request. And testing on the gRPC side was a little difficult. I was the one that did the work on that primarily, just because you have to have gRPC curl, and it's a little challenging. And then similarly with the job CLI as well. So just ensuring that we can actually pass that data from the local computer to the cluster. We have a reverse proxy that does all that, and then we have like a internal auth mechanism that handles the actual authorization. But it was just getting it to the pod to then redirect that traffic. But happy to talk more specifically, and we can drill down more as well.
Just to follow up on how you said sort of like it's a bit of a tangent, but did you look at using Istio or the service mesh rather than directly integrating multiple systems with Ray cluster itself?
Yep, yeah, we do use Istio. It's a part of it, but there's still, for example, Envoy, which is open source too, to actually do the reverse proxying start. We looked at a couple other solutions too for the reverse proxies, but yeah, I mean, if you have other ideas too, definitely all ears. I'm trying to learn as much as possible of what other teams are doing too.
Okay, great. Well, thank you so much, Peter.
Cool. Thank you.